Hi, I am Sikandar Rafiq and you are watching DevCore Learn Software Development channel. In this today's video we are talking about the data abstraction and DBMS. So this is very important episode. Let's deep dive into the data abstraction. First of all, the learning objectives. By the end of this topic, students should understand what data abstraction is, why data abstraction is needed, three levels of data abstraction. The lowest level is the physical level, then middle level is logical level, and then view level is the topmost level. Advantages of data abstraction and real world example of data abstraction. Introduction of data abstraction. You have seen the lot of applications, YouTube, WhatsApp, Facebook, and any banking app. So you view the information, search videos and chat, and update the profile, and you interact the application, focusing on what you need. But beneath the layers of this application, there are a lot of complexities, so you don't know about it. So there is a physical layer, there is how these data are stored in the tabs, how indexing are work, and how data is compressed, and how database pages and organized. So all these complexities are hidden from the user. So this is called the data abstraction. Hiding all these complexities from the user is called data abstraction. So here is the definition. Data abstraction is the process of hiding unnecessary implementation details and showing the user only the information they need. And the very simple definition is data abstraction hide complexities from the user. Let's see real world examples. So first example is the driving a car. So you drive a car as a driver, so there are a lot of things: accelerator, brake, and clutch, and then gear. So you don't, but you press the accelerator, then car speed up. You move the handle, gear. You move the handle, car handle, and car moves to the right side, or you move the handle to the left side, and then car moves to the left side. But you don't need to move what is happening behind. There are a lot of complexities. When you press the accelerator, and you don't know how engine is working, and you don't know how car fuel injection system is working, and how transmission system is working. So there are a lot of complex mechanism, but you don't need to know about it. So this is the data abstraction example. So it is hiding the unnecessary detail from the user, which is the driver, and only show the convenient interface. You only know about the handle, and then gate, and then brake, how to use the brake, and how to use the accelerator, clutch, etc. So another example is the TV remote control. You have the TV remote control, and there are buttons to change the channel, and there are buttons to speed up the volume and lower the volume. So when you press the button to change the channel, so there are a lot of complex operation being carried out in the background, but you don't need to know about it. So you just press the top button and channel is changed. So unnecessary complexities are hidden from view. This is another example of data abstraction. You want to change the volume, you press the top button and volume is increased. So there are a lot of operations being carried out in the background, but you don't need to know about that. You just press the button and volume is speed up or lower the volume. So it is just a convenient interface given to you. So this is because of the data abstraction. You don't need to know the complex operations being carried out. It is providing the very simple interface to you. You just press the buttons and all the operation is done. Why we need, there is very logical question, why we need data abstraction? Why we cannot go without the data abstraction? Okay, let's take an example and a scenario. If user without the data abstraction want to use the database, so it want to know how disk blocks are working, how B trees and indexes are working, and how database compress the data, and page structure and memory management. So by these things, there is a lot of complexities to use the database. So one cannot use the database without a lot of effort. But with the data abstraction, so it provides the convenient way to use all these databases or all the other things. So all the complex things are hidden. So it provides the very simplicity, very simple interface user want to use. So he don't need to bother about the complexities being done in the background operation. They provide the security, so unauthorized access. So in this way, all is handled by the application or the lower layers, and user can access all the features. There is a data independence. We will talk about the data independence in the next video, next week. So easier maintenance. So all these things are provided by the data abstraction. So because of all these things, we need the data abstraction. Otherwise, there are a lot of effort we need to know about to use anything, database, or maybe it's a car or TV remote control, TV control. So we have to gain all the background operation example knowledge, and then we will be able to make use of all that things. But here you have seen, we don't need to know the car operations, how engine is working, how fuel injection system is working, and the same is the case with the database. We don't need to bother about the complexities which is handled by the database. Okay, there are 3 levels of data abstractions. So here is the user or application. So you can use it hides the implementation detail and provide the data views only. View level data abstraction, this is the topmost level. So user only see the allowed data view. We will see the examples in the next page. So whatever the user wants or user need to know, it will see that view. So in the middle level, below the view level, there is a logical level, conceptual level. So in this level, it deals with what data we need to store in the database. So it deals with the schema information, tables, columns, rows, and how these tables have the relationship with one another. So all these type of levels handled in this level, and the developers will mostly work on this logical level. It is the logical representation of all the data. You have seen there is a student table, and then courses table, and then all other table which is required for the system. And below the physical logical level, there is a physical level. So in the physical level, we will use the storage level, blocks, compaction of the data indexing, and how pages are arranged, and etc. all these things. So this is the lowest level. Okay, we will see one by one each level. Physical level, this is the lowest level, as I told you. So in this level, we will deal with the how data are stored. So if we store the information, for example, ID is 101, and so then it will store to the, for example, page 20, and then offset is 5. So it will store the record here. So in this level, we will use the file management and compression to compact the data, to reduce the file size. Indexing, if there is some sort of indexing we need to apply, then we will use the indexing here in this level, lowest level. For example, here you can see indexes 1, it is pointing to page 20, this record, and this student ID is pointing to, for example, another page 21, etc. So all the data is stored in the disk here in this lowest level. Real world analogy of the physical level. For example, you have gone to the library. So here you can see the books, and only titles are there, and some numbers are there. You have seen this thing, but below what is happening there? So librarian is maintaining the shelf structure. For example, this ID 2023, it is, for example, shelf number 20 and offset to, for example, 300. So if you provide the ID, it will see what is the shelf number and what is the offset, and then it will find the book. So in this level, as I mentioned before, collection management and compression are done. So library collection organized in the large storage files. So indexing are done here, as I told before. For example, card ID is 101, so it points to the different shelf and location, row number 20, shelf number 5. So this type of indexing is done in the physical level. Then storage, so all these, by doing all these, so librarian will place the books in the shelf, which is resemblance to the storage. So in this way it will place the books here. So this is the real world example of the physical level. Then there is one upper level, logical level, which is also called the conceptual level. This is the middle level. It deals with the schema, tables, what data we need to store. For example, here you can see in the library database management, we need to store the student table. For example, this is the school management system, then the department, and then the degree program. So in the same level, we need to organize what relationship these tables. For example, student table has the related to the department. So it is 101. One student belongs to one department. Here 101 is Ali, and it has the ID 1. It belongs to the, for example, CS department, and Hang is belong to, for example, IT department. The same is the degree program here. So all this relationship we will define in the schema level. So ERD diagrams, etc. So SQL interaction are also there in the same level. So this is the logical level where we define the schema which store the data and relationships. Okay, then there is the highest level, view level. View level, you can see different view based on the user needs. For example, admin can view the whole data, ID is 1 and name is Ali and its sale is 100,000, so full table it can view. But employee view is restricted, it cannot see the some information, so it can only see the name and some other information, but it cannot see the salary, etc. and some other secret information. The HR view is the same, HR can view the whole table. So this is the view level information. So based on the rights, user can view different views. View level analogy is the same. For example, old file system, so it is the restrictions. For example, admin desk can access the whole files, employee desk can access only the restricted files, and the HR desk can also access the whole file system. So this is the physical access is controlled by the specific view. So this is the real world example. Okay, real world example, we will see the YouTube example. For example, viewer can see the comments and the likes, and this is the viewer can see. On the other hand, creator can see the revenue and subscribers and analytics. So creator can see the different view. Here you can see, and viewer can see a different view, application view. And the below level, view level, this is the middle tier. So here schema decides. So we have the different tables: video DB table, user table, and comments table, likes table. So it will store all the information. All these information will be stored in the database in this schema. And there are the relationships, etc. also there. So below the middle tier, there is a physical tier. We will use the indexes and storage and replication and sharding there in the physical level. So in this level, actually we store the data and how we will store the data. So all these types of the we are applying indexing, storage, replication, sharding are there. So all these techniques we are applying to store the data. Another real world example is the WhatsApp example. So this is the user view level. You can see the user can see different views. One user can see the chats and other user can see the profile view. So this is the view. Okay, below the user level view, there is a middle tier schema, user table, comments, likes, and revenue. All the tables storing the data. And below the middle tier logical level, there is the physical level, same indexing, disk pages, data blocks, and the replication and database internals, sharding, etc. So here you can also see the three levels. This is the topmost level, this is the middle level, and this is the lowest level where data is stored. Okay, this is the complete architecture, user and then view level. So visible information based on the user needs. Then we have the logical level, tables, columns, and relationships exist on this logical level. Then we have the physical level, files, pages, indexes, and stores are there, and then storage are there, and then it is all the data is stored in the disk. Advantages of data abstraction, as we have seen, the simplicity, security, easy maintenance, data independence. We will talk about the data independence in the next video. Better scalability. So by using the data abstraction, hundreds of thousands of users can use the same application. Okay, here is the summary table. So view level, what user can see, and it is used by the end users. Logical level, what data is stored, so it is used by the developers. And the physical level, how data is stored, DBMS and DBA. So we have seen the how we are saving the data using the indexing, replication, and then sharding. Okay, the final key takeaways. Data abstraction hides the complexities from the user. DBMS provides 3 levels of data abstraction. Physical level describe how data is stored. Logical level describe what data is stored, and view level describe what user can see. So we have discussed all 3 levels in detail. Data abstraction improves simplicity, security, and maintenance. So this is the key takeaways of the today's video. Thank you so much for watching the video. Keep watching. Bye.